When I gave the title of this talk, and when I was asked to come in and share this, it was kind of a joke at first. I thought it was funny, and then and I grew to like it. I really like the title. We're going to take the I out of PaaS. So hopefully I will bring meaning to that shortly throughout this talk. I also have a lot more slides than we'll probably get through. I'm not sure how you will get them, but you're welcome to them. So, and there's an email address if nothing else works out. So Ken, I'm employee 22 to a company, so I get to be Ken, right? It's exciting. So a little bit about me. I'm not going to spend too much time on it, but prior to joining Mesosphere, I was actually, first of all, I'm a developer. I'm mainly a developer. I've been a Java developer since 97 actually. I started out doing C++ work. Before joining Mesosphere, I was heading up research at Savis, which is part of CenturyLink. They're the third largest ISP in the country. And the question that they gave me at that time was, where's the cloud going to be in 2 to 5 years? I'm like, that's crazy, Doc. Humans are predictably terrible at that kind of thing. So let's have a quick conversation. I love this question, but I'm increasingly finding it difficult because there's an increasing number of people who have no idea what I'm talking about. Like, when's the last time you've seen the Twitter fail well? Like, we could Google this up and go in the Wayback Machine, we can find it, but it's a really cool question. Now, there's a couple of things that happened at Twitter roughly at the same time. They built an architecture which I jokingly refer to as the Monorail, a monolithic architecture on Ruby on Rails, right? So the Monorail was a complete fail, and they blamed a number of things. One was working with a dynamic type system. That aside, 2 things happened roughly the same time. First, they moved to the Java ecosystem, so they're mainly running Java. But the second thing that happened is they moved to Mesos, Apache Mesos, and that was in the very early days of Mesos. And Mesos, for the most part, grew up there. I'm not allowed to give their numbers away, but they're in the tens of thousands of nodes of a cluster, and we'll talk about what that means. But this is very relevant to our conversation, I think. There's multiple reasons why an organization or group might consider going to Apache Mesos, but one is for scale. So here's our agenda. Again, I might not get through all of this. I definitely want to get some demos in place because that's fun. And I was sharing, I deleted code last night as a sacrifice to demo gods, so I think it'll work. We'll see. So we're going to talk about the legacy data center. And the funniest part about calling it the legacy data center is that it's probably the data center you live in today. So it's really weird to use the word legacy when you mean current, but the reality is there's a lot of legacy thinking that went into that. Now, I'll also say that I'm from St. Louis, so I'm in the Midwest. I'm one of you guys. Right? But I have built my career going out to the West Coast, finding out what the cool kids are doing, and in 3 to 5 years, it's important here. And I'm an expert at it, and they pay me well, right? Now it's a little bit weird because I work for a company that's on the West Coast, and I don't get any of those advantages anymore at all. But what I'm going to share with you is what the cool kids are doing on the West Coast, and it's really quite different than what we're used to. And again, I've been working with a number of organizations. It seems hard to get folks in the Midwest, organizations in the Midwest, to actually move in a non-conservative way, like they're looking for proof, right? And hopefully I'll share enough stories to share that's actually there. So the data center. What is special in the data center? And there's a perfect storm brewing. Here's what it looks like. The first is that how would we describe a legacy data center? Well, first I would say that it's statically partitioned. And what that means is we have a number of hardware machines, we have a number of nodes, and we slice and dice those nodes by VMs. And then we statically partition them. And you know you're in a legacy data center when you start treating machines like pets, right? You give them a name, and you take care of them, right? So what we're going to do is we're going to say those 9 things are for Hadoop. And we got Hadoop 1 and Hadoop 2. We can go through it, right? Humans can understand it. You've given them names. Now, here's another way you can identify a legacy data center. For a large data center in a legacy world, what you would typically see is thousands of chef's recipes or puppet recipes, right? You see thousands of them. And what does that mean? It should be meaningful when we say that. What it means is everything's a frickin' special snowflake, right? Everything's special. And what we're moving towards, if you're in the tens of thousands of commodity servers, nothing can be special. Otherwise, it's overhead, right? So we're going to try to commoditize everything, which means we should be in the tens of recipes, or maybe hundreds. Not everything is generalized. We can talk more about that in a second. Right? So we see those 9 things are Hadoop. These 10 things are for web services, so we get our Tomcat instance or whatever and those things. And now you want to repartition some things. You're like, I need more Hadoop. I need more space for analytics. And that movement right here, this to this, takes at a minimum hours, probably days and maybe weeks for an organization to make that transition. And what's worse is, oh crap, I need those resources. Going back takes roughly the same amount of time, right? Unless they have a fallback plan and things like that. But generally speaking, it's not dynamic. And so that's what we mean by statically partitioned. Now, the other thing that happens in a statically partitioned world is like, well, I can't give away some names, but I went overseas, worked for this large organization. They're competitive with Amazon. And I'm asking them, why are we here? What's our objective? And they're like, well, we have 5% utilization. That's where they're at. That's really, really common. Generally speaking, most data centers are under 20% utilized. Less than 20%. That's crazy, right? And I would submit that you will never get beyond 75 or 80%. Never. Why? Because we have bells and whistles that go off on an individual machine when it hits 75, 80%. And then humans come in, storm it. Like, how do we fix this? So we have a statically partitioned world. Why? Well, because we have humans involved. They need to know, how do I debug this? Where do I go to tail something? Where do I go? I need to know that information, right? And that's largely because we've never had really great tooling to solve that problem. And that's just been the legacy world, and it's been acceptable. And we have known resources and ports. So it's a lot like on your laptop. Any modern laptop's going to be multi-core, right? You're going to have 2, 4, maybe 8 cores on your laptop. It's a lot like being prompted with this when you launched a browser. Which core would you like to run that on? Right? That's a ridiculous question. Now, why is it that we do not have to answer this question? It's a good question. Why do we not have to answer that question? Well, because we have a scheduler. We have a scheduler on an operating system level that manages the prioritization of processes, and I never have to answer that. Now, could I, if I really wanted to? Yeah, I could have core affinity if I really wanted to, but generally speaking, I prefer an environment where I don't have to worry about that, right? So we have the option, but it's not required, and the general accepted practices, we never answer that question. In fact, think of it this way. What is the difference between one node that's got 100 cores in it and 10 nodes that have 10 cores in it? From a resource standpoint, they're the same. But from an operational standpoint, they're very, very different. And from a programmer standpoint, they're also very, very different. Crossing a network boundary is a very different experience. I have to be prepared for things that I do not have to be prepared for on a single node. But what if we could abstract that concept? And that's kind of where we're going with Apache Mesos. Is the value that we get with Apache Mesos, is to never have to worry about that question again. We can also look at resource utilization, and if you were to look at the utilization curves that we tend to see, what you would typically see is a curve that would be a peak on peak time for your web traffic or microservices, whatever you want to call it. Now, you might have multiple peaks. Those peaks, by the way, when we start doing capacity planning, the thing I have to worry about is the peak. But not just the peak, but maybe the peak during the peak season. So as an example, the floral industry, which I actually wrote some code for in the past, they have 2 peak times during the year. Anybody want to guess? Mother's Day? Valentine's Day. You know what? For a month and really 2 weeks prior to those events, you need a data center. Any other time, you need a machine, right? That's just the world we live in. So how do we manage those things? So when we're doing capacity planning, the thing that we have to be concerned with is I need a data center that is maxed out, peak time, during peak season, and then double or triple it. That's typically what we do. About twice as much as that. And that's how we do capacity planning. And that's also why we're at 5-10% utilization, generally speaking, in the data center. Now, what if we could repurpose that? What if we could do something else with it? And I'm going to share a story in a second about Google. So we're going to put this in a virtual machine. This is the legacy world that we do things in, right? We take a VM and we stick an application in it. And now that VM does this thing, whatever that is. Now, there are 2 models we tend to work with in that. They're not mutually exclusive. The 2 different models are recipe-based. You have a chef recipe, and in the data center, you have a naked VM, and then you say, create me one of those things, right? That's one way. The second way, which is becoming increasingly popular, and it's made generally popular by Netflix, is we take a recipe, we create an image, and whenever I want to scale something, I spin another instance of that image up. Now, I want you to think about one more thing when we talk about that. Because of that, the consequence of that, if you're looking at AWS as an example, when I scale something, I have two things that are coupled together, and they're stuck together. In fact, they're so stuck together, we don't even think about them being separate. And that is capacity and scale are coupled together. If I want more scale, I increase my capacity because I don't know another way. In the legacy world, there isn't another way, right? Those two things are coupled together. We're going to show and talk about a way of decoupling that. Now, I have a ton of wasted space, potentially. I have a bunch of wasted space here. You can see that I have some inverse curves. Typically, the analytics is the inverse of peak time. That's typical. But we could bin pack these things on a given VM and save a lot of space. And in fact, there's an interesting use case. It predates my joining Mesosphere, but there's a use case where HubSpot, for administrative reasons, went to Mesos. Now, they're completely EC2. One of the benefits that they got out of moving to Mesos on top of EC2 was they reduced their Amazon bill in half. They went from $160K a month to $80K a month. That's a pretty big deal, and it has a lot to do with this bin packing that we're talking about. There were additional reasons that I could go through later if you're interested. Now, this is a very interesting story as well, is Google. I don't know of another organization that has more experience working with containers than Google. It was top secret when it was first came into existence, but we now know it as the Google Borg. The question that they had was this: I have this huge data center, and I have enough capacity to manage my peak times, but generally speaking, I have a lot of capacity. What if I could use that for business purposes? How can I do that? That's what the Borg is. The Borg is a scheduler, and it allows you to schedule and preemptively instantiate and remove instances of processes based on load conditions, right? That's essentially what it does. Now, a really cool thing here, Google created this. It was top secret, but they were still sharing some of these things with academia years ago. And again, this was around 2008, 2009 timeframe. You can also correlate that, by the way, with Linux. The LXC standard came out around 2008, 2009. That's an interesting correlation, yeah. But they were sharing this with academia, which included UC Berkeley, and at UC Berkeley was Ben Heinemann, who's the founder of Apache Mesos. So Apache Mesos, in many ways, was inspired by the Borg. There's some differences that are very significant. You can read about many of them on Google's research paper, where they do some comparisons of the Borg versus Mesos versus Omega, and Omega is the replacement for Borg. So it'd be worth taking a look. They make some negative cases about Mesos, and almost every one of those negative cases have been resolved. And one of the major differences that's worth noting about Mesos is uniquely a two-level scheduler. That means that Mesos itself understands the technical primitives of remote computing and scheduling and working with a cluster, but it doesn't have any intelligence as to what to do. That intelligence is added at a second layer, which we commonly, in the Apache world, we call it a framework. So that's a strange name, but a framework is a second scheduler that has the intelligence of what to do when something fails, essentially. So that's the core of it. Another challenge in the data center is time to market. Now, there's a bunch of things that are converging all at the same time, right? It started probably with craftsmanship, maybe with agile, with continuous delivery. We now call it DevOps. It's all kind of the same concept, right? Which is, how do I get a faster time to market with quality product? That's essentially what it is. Now, an interesting story, the CEO of our company is Flo, and I've never talked to him about this, but I know a little bit about the story. He is the person who created user search on Twitter. And his claim is that it took 10 weeks when he finished creating code, he was done with it, 10 weeks between being done and users being able to use it. It's an interesting window, right? Now, I've not talked with him about it, but one can imagine the things that would slow that down, right? Well, we have a release plan, and during the release plan, we have 3 new features that are going to go together. So I'm coupled to something that has nothing to do with user search, probably. I'm going to build a staging environment. Now I'm going to create a bunch of chef recipes that create that environment, and I need to get that in staging and QA, and then once we're all happy, we can VIP switch, and now I'm in prod, right? Those are the kind of things that we would need to do. It might be useful to know or interesting to know that at Twitter, they release multiple times a day today. So Apache Mesos is an enabler for that. Now, there's some maturity that you would need to bring into your apps development in order to make that happen. A large part of that would be making sure that you follow 12-factor, among other things. So if that's new to you, hit me up with some questions. We also kind of focus in the legacy world on VMs, virtual machines. And they're just fat, they're heavy. Now that seems like a subjective term, but we can also give it relative to things, right? A VM tends to be roughly 2 gigs in size, and if I make a small configuration change, I get another 2 gigabyte image, right? And it depends on what your rollback plans are and what your historical capabilities of rolling back are as to whether that's significant to you or not. They're also very slow to start up. They're in the tens of seconds to start up, and that's nothing to do with any service inside of it. That's the VM. That's just the machine starting up. They also consume a lot of space. Now, my research shows that between 5 and 15% of the data centers consumed by virtualization. That would be the guest OS and hypervisors, things like that. So it consumes part of the data center in order to establish this infrastructure. And so we could start talking about the delta between this and containers, and I'll share that in a second. I have a bunch of slides I'm just going to pass through. All right, so what are the trends of the data center? The trends of the data center. So the first is this new classification of applications. So traditionally what we've done is we've taken a VM and we've stuffed an application in it, and that image is that application, and that's all there is, right? The new world kind of moves in this direction. We're increasingly seeing applications which use an aggregation of services. In fact, ask your ops person, where is the Cassandra? Where is that? Like, well, that's really a bunch of slices of processes and data. It's conceptual. It's a conceptual concept. There isn't a thing that runs that is the brain of Cassandra. It's a bunch of collaborating applications that know how to manage the app together, and the whole thing is Cassandra. Does that make sense? You could also add probably Cloudera, Hadoop. They all fit in this similar space where they vary in how they collaborate across the aggregated cluster, but they still consume more than a node, and they consume a varying size of a cluster. So we're increasingly seeing that as the new way we see applications being developed. There's also this need for aggregation, and typically when we talk about aggregation, we're talking about those 3 things: CPU, memory, and disk, and we want to aggregate across the data center. You could also talk about, at this point, isolation. I want to be able to isolate those things. And so making sure that you get a slice of time that's uniquely yours and not and can't be taken away from you, right? That's an important concept. We talked a little bit about elasticity already. Some use case studies. These are going to be great when you're looking at slides by themselves, but I don't really have any conversation to have around that. Another trend we're seeing is containers. Now, at Mesosphere, which is where I'm from, we actually don't care about the brand. We do feel like containers are the future, though. But the branding, the brand that has won the heart and minds of developers is Docker. So we play nicely and well with it, right? It's an important thing. And we can talk about the varying challenges with one container versus another, but certainly containers are the future. We currently have a problem in this space, and it's usually around isolation. It's still possible from a security standpoint to break out of a container or affect a node, depending on which container technology you're using. So we have some things to work out. I don't know if I like this slide terribly, but it sets a standard. We're sitting on top of Linux. Currently, Docker is Linux only. We are seeing Docker as well as Mesosphere work with Microsoft, and Windows 2016 actually has concepts very similar to C groups and namespaces. So we're going to see true native containerization on Windows shortly, which is great. Here you can see it started out with LXCs. Today it would be libcontainer. Hopefully in the future it'll be the Open Container Initiative. It's yet to be seen. But there's some kind of containerizing technology slightly above C groups and namespaces. By the way, I won't have nearly enough time at all to go through this, but if you're using Java inside of a container, you might want to send me an email and I can send you some details. I've been meaning to blog on this for a while, but there's some interesting challenges running Java inside of a container. And I've already been working or talking with some of the guys at Oracle, but haven't really seen any movement. So I'm just trying to spread the word. All right. What else? So containers are, the beauty of Docker is it's an immutable container. Now, there are some strong differences in the Mesos world. We have a Mesos container and the Docker container. We work with either of those. One of the strong differences is that a Mesos container is built on the fly, whereas a Docker container is built once and it's just a tarball that's moving around, and there's some beauties to that. There are some big negatives, though, within the Docker space. Again, if you want more details, hit me up. I'll leave some Q&A questions time at the end. Now, as soon as people start working with Docker, this is like the first question that comes up, and this came up a long time ago. It's on Stack Overflow, as you can see, and it's like, how do I scale this thing? This is really awesome. What do I do with it now? And what was beautiful is last year, it's been a year and a month ago now, last Docker EU, Solomon, who's kind of the voice of Docker, at that time said that the only way to go high scale is with Mesos. It's awesome, right? Nothing like getting an endorsement like that. Now, what you'll see for answers here are all kinds of things like Orchard, Shipyard, a variety of solutions. So the beauty of having Apache Mesos is it can work on-prem or in the cloud, and you have a lot of control over things, which is not entirely true with all the options up there. Now, Docker has their own solutions, of course, like with Swarm. They also have Compose, which used to be Fig. I don't mean to challenge that entirely, but they are relatively primitive at this point, in my opinion. So, look forward to seeing if they evolve that technology. It'll be great. But if you're looking for true scale, in-production type solutions, and something that's been battle-tested and hardened at scales of tens of thousands of nodes, that would be Mesos. So, and then, of course, we have this interesting thing that happened at DockerCon 1, the very first one, right? The very first DockerCon, Eric Brewer came out and announced Kubernetes. Now, there's an interesting thing that happened right at this time. They're like, hey, they're releasing the Borg, and they're making that open source. None of that is true. There's not a lick of code that came over, not even people who were involved. And then they're like, oh, we're releasing the Omega. No, this is completely new code. So if you're looking for a Docker-only PaaS-type solution for Docker microservice-based solutions, then Kubernetes might be worth looking at. We do have a project, though, which is Kubernetes Mesos, which allows you to put Kubernetes on top of Mesos. So that's a very interesting option for you if you're interested in that. Another trend that we're seeing is a movement from the monorail to microservices. In fact, that's kind of the new buzzword, right? You have to say it. You have to add it in a talk and a slide. You got to buzz, little lights go off. Microservices? And you can't say microservices without talking containers, like it's a required thing, right? They're kind of blended together. So that's the future that we see that we're moving towards. And that's been true, actually, for probably a couple of years, actually. It's maybe becoming more mainstream and considered an option in the Midwest now, right? We're getting really close. It's exciting. All right. You know what? I'm going to pause for a second. Why have goals? That's ridiculous. I'm going to show you a quick demo just to give some concepts. What we're looking at here, it might be tough to see in the back, but every time you see a 0 and a %, there's a donut around that, and the contrast has to be right to be able to see the donut a little bit. We're looking at memory. Every donut that you see there is a node that's running on GCE. So currently I'm on GCE. This is demo, so there's some things in here that are completely demo, but it is running on a real Mesos infrastructure, and I'm just trying to get some concepts across. What you see on the right-hand side, your right-hand side, is a list of services, and right now you're seeing Marathon and Kronos. Marathon runs long-running processes, something you want started up, and then it just stays running, and if it were to fail, it would start it up somewhere else. It's essentially the init system of the data center, just like you would go to init or Upstart or something like that on a Linux platform. That's what Marathon is. Kronos, and the funny part here is that crons have been the single point of failure in all data centers. And it's kind of funny, but it's true. Like, it's on a machine, and you can't build any kind of fault tolerance to it whatsoever, and we just tolerate it. It's always been the single point of failure, and we just find ways of managing that. What Kronos is a highly available cron solution for the data center. So the standard things you would expect to see in a cron solution, scheduling of time-dependent processes, things of that nature. So I've logged into the server, which is going to be a little bit different than the next demo I'll do. Here I'm at the command line, and I'm going to just, hopefully someone's already done this before, so, whoops. Okay, so I'm going to say DCOS marathon start, and I have a JSON file that describes a job that we assume to be like a Rails application. Now, the beauty here, of course, is that I asked for this to be scheduled. Uh-oh. And it's not very impressive right now. I tell you, I did delete code to the demo guides. I don't know. Oh, there we go. Patience can. Okay, now here's the beauty. The beauty is this. I did not tell it where to go, right? It just knows that I need that, and then it just scheduled it. It feels very PaaS type solution oriented, right? Like, these are the kinds of things I expect a developer, as a developer, I want to have happen for me. Now, the kind of things in addition that are kind of invisible to us is, that is a Rails app. A Rails app would be a web service. I obviously want that behind maybe an HAProxy. So registration to HAProxy should already be there, and it's connected. That's great, right? Now I'm going to show you something really conceptually powerful, I think, which is I am going to scale that application. Now, the beauty here is that, once again, I have absolutely no control over this. I don't care where they land. Notice a couple of things. First of all, based on some assumptions that whenever I had an instance, I had 19% of memory consumed on that node, we can pretty much tell that there's 2 instances on that node. There's 0 here. We can start getting into some interesting questions. Like, people will want to know, well, don't you want to make sure that we have fault tolerance, and don't I want to control how many? Do you really care? Do you really want to know that? Like, there are times when you want to care about that, truly, right? But don't you want to declare that as a way of solving the problem, as opposed to being a human that says you need to be on Hadoop 1 or on Web Service 2 or on, like, how much maintenance do you want to be involved with it? Because here's the issue. What if it fails? What if that node goes down? Then it should be able to recover. Now, what I didn't say is that all of those things now register with HAProxy. Now we've done something that we haven't been able to do in the legacy data center, and that is we've completely decoupled capacity and scale. I changed the scale of this application and did not affect at all the data center capacity. If I want to add capacity, that's a different concept. Certainly, I could scale this to the max of the data center, for which I would need more capacity to be able to add more scale. I get that. But now I have 2 different accesses I could run on. Does that make sense? It's a really significant deal, and it's architecturally something you weren't capable of that before. It's a really big deal. So let's add to this just a little bit. I can go in here and say I want DCOS install Cassandra, and DCOS install, if I could spell, Spark. And it might take a few seconds based on how speedy those VMs are, apparently. But you can see that there's services being added in. Now, a beautiful thing, right? Now this is very meta at this point. What I've done now is I've added in the capability to do Cassandra-like things. Before, it didn't have it. I didn't add Cassandra, but now I can add some Cassandra stuff. So I can go in here and I can say, you know what? I want to DCOS Cassandra add 6. So now we see something really interesting, right? What usually takes, I don't know, weeks of time at a minimum to install a Cassandra instance into production, we can literally do in minutes now. Now, there's a lot of assumptions there, right? The assumptions are that I'm taking the default configurations, and you may not want that. There's a variety of things we'd want to expand beyond what we just did. Notice that they're all on different nodes, because that's what you would want with Cassandra. Notice that they seem to be relatively quick. Is it really installed now? No, it's not. The resources have been reserved for Cassandra. It's currently being provisioned. Once it's provisioned, it'll be ready to be played with. We can go one step further on this particular demo, and I could say, you know what? I want to run a Spark job. Now, when we run a Spark job, what I'm really wanting it to do is just to consume the rest of the cluster. Like, just spin up MapReduce jobs across the rest of the cluster and start utilizing it. So you'll see a bunch of numbers jump here. We might even want to switch out to instead of looking at individual donuts, looking at the capacity of the entire data center. So now we're looking, in particular in this case, at memory on the entire data center and how it's being utilized over time, which is really, really cool stuff. Notice we're well above 20%, which is the average we tend to see in data centers. So this, by the way, is the secret of the Borg. You'd have to go a few steps further than this. The secret of the Borg is that there's untapped capacity which we could use for analytics. And the reason why Google, my opinion, Ken's opinion, not Mesosphere, Ken, right? My opinion as why Google is so far ahead of their competition is they were able to do a whole lot more with their data center than any of their competition. And they've just always been ahead because of that, right? The things you would need to add in addition to what you see here is you would need to add preemptive capabilities. And what that means, what you would see at Google is the definition of two different classifications of services. One would be like a guaranteed service. This is always guaranteed to have resources available to it. This is best of service. Two different concepts, right? So think about it this way. What if I looked at my data center and I said, you know what? Search, web traffic is the most important business value that I provide. Well, I want to guarantee that 60% of my data center is available for web searches, but we're only using 20%. So there's a difference between the reservation line and the utility lines. Everybody cool with that? So I'm reserving 60%, but I'm only using 20. So I could have my best of service, my analytic jobs, just consume 80% of the cluster. And as web traffic picks up, you're like, uh-oh, I need more resources, and I'm guaranteed up to 60. And then you just throw out any web MapReduce jobs because they're best of service. Does that make sense? So that's the kind of thing that we see as the future. A lot of organizations haven't got to that point. Frankly, there are three different types of users of Mesos from what I see. One is those who are doing analytics. We see a lot of, in fact, Spark has taken over the world, it seems like. So most organizations are moving away from Hadoop into Spark space, it seems like. The second is my microservice friends, right? Microservices. And the third is a little bit more mature, and that group is that combination of workloads, where I actually am doing analytics of the leftover utilization of my microservices-based platform. So that's kind of the future of things. You know what? Maybe I'll pause for... Oh, no, we have a mic, don't we? I was going to pause for any questions. Maybe we can do it. 2 minutes. Questions on what you've just seen so far. Anything? Did you understand anything I said? Yeah, okay. Or you're laughing because you don't understand. Okay. All right, I got plenty. We can move on if you want. What I want to move to, this was demo world, right? I am going to slowly transition into the real thing. We have a product which we do have a community edition of, which we call DCOS. It's the Data Center Operating System. And I'll have some more slides, but this is the core of it. This is what it looks like. If you were to look at just plain vanilla Mesos, it's an open source thing, right? For those of you who remember the past, some time ago, we all used Bugzilla to track bugs, and it was ugly. It worked, it was cool, but it was ugly. It was really ugly. And now we have like Jira, which is, I don't know, I have my different opinions on it, but it's prettier than Bugzilla was. That said, that's kind of what we see with Mesos versus DCOS. DCOS adds a lot of more features than Mesos, but one of the really cool things is we put a nice UI on top of it as well. What's really cool, though, is that if you take a look at Mesos itself, let me do that for a second. Let's just look at the Mesos UI of this is a real cluster, live, right? Now, I've switched to going to Amazon. Everything you're seeing now is on Amazon. This is a master with 6 slaves. You can see it. By the way, we're switching some of the terminology. In the future, you won't see slave at all. You'll see agent. So, but just be prepared for that. We have 6 of those running, and I have a master. That's what we're looking at here. There is a RESTful endpoint or API to most of these open source tooling. If I went to the state.json file, this is liar. You would have a JSON blob of like the entire, like what's going on in that cluster completely. Now what's really fascinating, and I'm not trying to talk you out of using DCOS, because that's my company, right? But the reality is that pretty UI is a really pretty UI of the thing that you have full access to as well. It's just a nice, pretty way of providing a graphical user interface for humans of what that JSON file says. That's the core of it. There's more to it than that, but that is a big piece of it. So, and the beauty of it is this. You have full access from a RESTful endpoint to be able to provide monitoring, say through Graphite, or to automate in some way. You have full control and access to Mesos or to Marathon, which is really, really cool. Also, any of those tools, Mesos or Marathon, you could do a slant help on it, and you would have a live API on how to use the API to, in this case, Mesos. So you can get access to like health and state and roles and reservations all directly, all programmatically, right? So that's a very important thing to us, is that we're at our core an open source company, right? Now we're going to make our money off of a product, but we're an open source company. We want anybody to be able to extend this into whatever environment they're in. We're never locking somebody into a specific thing. So that's, I think, a very important thing. And so far, it's always been true, which is great. So this is Mesos, and we put a nice UI on it. You can see that there's nothing running. We can see the number of services. Another thing here is I'm going to switch now to command line, and I'm going to just exit this green one down here. The green one was, I was actually logged into a server. This white one now, this is on my laptop. So I'm now on my laptop controlling a cluster that's on Amazon. And then some things are slightly different because we had our demo world that was kind of here's the concept we're after, and then we went to the real world and we had to make some changes, right? So here we can say DCOS. I can say node. I can get a list of all nodes that are currently running. I could go in here and say, you know what? I want to be able to go to a given node. In this case, I want to go to the master, and I want to SSH into that master. So it automatically knows that the details necessary to get me to the master, and boom, I'm into the master. If I want to go look at tail logs, things like that. Thing is, though, if I wanted to tail logs, I actually wouldn't have to go that far. I could actually say DCOS node tail. It's log follow, and then I could specify a given task or a master, so maybe the master. So what I'm doing now is I'm actually doing a follow tail log on the Mesos master. It's tailing the master at Amazon and then streaming that down to my laptop, doing a follow. So here's the cool part. All the challenges we had before where humans have to be able to find something, and it's like I have to go to Hadoop 1 and I need to know where that's at. All I needed was the tooling to allow me to do that, and now we have it, right? Now it's possible. If we went in here instead and said, I want DCOS task instead, you'll see that there's nothing running. So that's task essentially is like doing a PS on the cluster. So let's do something with it. So in this case, unlike the demo, I'm actually going to do an install of Cassandra and actually install Cassandra, the real one. So we'll see how long that takes. The beauty here is if I went down, it's going to take a few seconds. Let's verify some stuff. There it goes. Okay, so we have Cassandra being launched here. I've integrated the UIs. We got a really nice UI where I can see Marathon right here off of the slide window. If not, I could go to the full screen. It's some pretty cool stuff. I'm going to go back. What I wanted to share with you here is that the Cassandra right here, it says it's unhealthy. Now here's the beauty of this. When this says it's healthy, it means that a CQL can execute. The health check is literally CQL. So not only is the process up, and not only are they talking, but I can actually execute commands. And if not, it's not healthy. So we'll wait for that to get healthy. It's going to take, I don't know, it takes sometimes 10 minutes or so. A whole Cassandra cluster in 10 minutes. How cool is that? It's pretty cool. It's pretty cool, right? All right. Have you guys not done? No, Brent. All right. So we'll let that settle in while we continue on, talk about some of our goals. Remember the talk here was taking the I out of PaaS, right? That's a weird title. The traditional world that we look at when we look at moving services out and is really about taking ownership over less, right? Frankly, if you look at why developers or organizations move to a PaaS solution, the core driver almost always is developer enablement. I want to remove ticket systems out of the way. I want to remove ops and all the barriers for moving something out to production. So when I want to upgrade a service, I want the upgrade to take place, I want the load balancing to take over, I want DNS entries to be added, I want all those things to magically happen for me, right? Now, it's been presumed or assumed that when I have an on-premise solution, that the next step in evolution is the infrastructure as a service. And if I can build that in place, then I can build a platform as a service. Now, the reason why I gave this talk title is because of this assumption. Now, I'm not saying don't do that. That may be a great solution, and we talked through some things over lunch or just before coming in here as to why an infrastructure as a service might be of value. But when is it not? When is it not? So we weren't allowed to talk about this as far as Mesosphere was concerned for some time, but Apple did us a favor, and they announced it themselves. In April of last year, they announced that they moved to a project they call Jarvis, which is kind of a nod and wink to Iron Man, right? Jarvis is their code name for essentially Apache Mesos inside the Siri data center. Now, there's a couple of things to know about virtualized platforms. I mentioned one of them already. About 10% of the data centers consume with virtualization. It means you just lose it. It's just the cost of virtualization. We just buy more hardware to be able to tolerate that. The other challenge you have with infrastructure is that it costs you money. You're going to pay subscription fees. The third thing, and this one's the big one, is that we know, generally speaking, that VMs don't scale when it comes to I/O. It's the reason why you don't put databases under heavy load. You don't put them on virtualized platforms. You put them on bare metal, right? Now, if you're able to run a database on a virtualized platform, that's great. It means you aren't at a heavy enough load where that's a concern for you. That's great. Don't worry about it. But at really heavy loads, I/O doesn't scale. And if you look at the VMware site or any of these VM company sites, you'll see details on how to squeak as much I/O out of a virtualized platform as possible. There's good documentation on it. So it turns out that Siri is an I/O intense application. That's what it does. So when they moved to Apache Mesos, what they did is they ripped out all virtualization. What happened? They ripped out all virtualization. That means they gained 10% of a very large data center for free. Like, they already paid for it, of course, but like, they don't have to virtualize anymore. It's just bare metal. Now they can have the highest capabilities of I/O scale. Now they don't pay millions of dollars of fees to VMware in order to have a PaaS solution. So my point is that it is possible to have a PaaS solution without an infrastructure as a service platform underneath of it. It's just something we don't think about, but it is possible. And there are organizations on the West Coast who are doing it. So it's very interesting. It's an interesting concept. Now here's the real beauty about being on top of Apache Mesos. It can fit on bare metal, clearly, but it can also be on top of a cloud solution. So on-prem, you could utilize as much of the data center as possible, but you can still shunt traffic or move services out to Amazon, out to Google, out to Azure, and have it kind of as a safety margin. Like, as long as you can establish Mesos as a cluster on any cloud, you can always move your services to it. Does that make sense? So there's some really, really cool benefits to it. And as we already talked about earlier, on a virtualized platform, I can still save I could still maximize utilization and save costs because I can bin pack on top of VMs. I'm using the VM not for a specialized application, but for the movement of apps by Mesos. Now, there's one other really positive thing about being on bare metal, and that is, and this is a little bit more complicated to understand potentially, but as I slice up a physical machine by VMs and I start bin packing apps on top of that VM, I actually cause more fragmentation that maybe Mesos can't use. So if I have a half of a core left in this VM, or maybe half of a meg in this VM and another half in this in this VM, of all the VMs on that hardware, I might have 3 gigs of memory, but Mesos can't schedule against it because it has to be fragmented into whatever's left inside that VM. Whereas if I ripped out VMs completely and let Mesos do all the bin packing, it would manage it more efficiently. So there's an additional benefit of being on bare metal or not virtualizing. Now, with that said, there's benefits to virtualizing, and one of them, which hasn't been talked about yet, is virtualization is the best isolation from a security standpoint. So there may be reasons to still virtualize from a security reason standpoint. There are folks working on essentially what is the hypervisor of containers, but we don't really have a good solution in that space yet. A place to look if you're interested would be LXD, which is LXD, but pronounced LXD. All right. We've got 15 minutes. Good. You know what I'm going to do? I'm going to bypass some of the fluffy stuff and talk about Mesos directly. So a common stack for us might look like this: Apache Mesos, Marathon, Kronos. My understanding is that there's people or there are organizations within Cerner who are already using most of the stack. So what is Mesos? So Mesos at its core is an Apache open source project. It is written in C++. Get a lot of challenges to that as to, hey, do you think about, no, we're not going to rewrite it. We're not going to rewrite it, C++. Now, one of the benefits is that it's like a 2 megabyte exe. It's really small. Also, it can be confusing because we talk about the Mesos master and the Mesos slave, but the exe, there's only one. There's one project for Mesos and there's one output. It can run in a slave mode or it can run in a master mode. So it has two different modes that it will run in, but it's just one exe. It's built to scale to tens of thousands of nodes. We've done our own testing to 50,000, I think, somewhere around that neighborhood, which is a lot. The idea and concept is we take a cluster of nodes and we make it look like one node. There's a scheduler now, and the scheduler is at a data center level and not an operating system level, meaning a node level. We can work on bare metal or VMs, doesn't matter to us, and you can make a combination of those. It's just resources. Also, I don't usually get into this level of detail, but it's kind of cool. There are two things that are always served up from a slave or from an agent, right? One is an attribute, the other one is a resource. Now, what's awesome is both of those are arbitrary. So, by default, resources would be CPU, memory, ports, and disk. But you can create any resource you want. And a resource is something that's consumable. So you could say, this node has one banana. And if you have a job that takes a half a banana, well, half a banana's gone, right? It's anything that has a scalar value with any arbitrary name. And so you can have your own set of resources if you want. The other that gets served up is an attribute, and attributes are commonly used to delineate different things. One example would be this node has an SSD card on it. This node has a GPU on it. This node belongs to fault domain 1, or this one belongs to fault domain 2. And you can leverage those attributes with some kind of declarative reasoning so that I can say, I want these things spread out across fault domains so that when something fails and the scheduler starts it back up again, it will start up without a human being involved in the most healthy way possible, right? So that's one of the really core concepts of Mesos. So I can get into cells and biology and looking at the system as opposed to nodes. We're so focused on nodes, right? Like if you're a developer today, you're like, well, you get this node and it's going to be Hadoop 1 and make sure it's installed. It's a lot of work. You're like, you should just I need this installed. Let the system do that for you. There's a picture of Ben Hyman and his focus on what Mesos is all about, which is to make it as easy to create applications in the data center as it is for your laptop. And if you get a chance to hear Ben, you should take that opportunity. It's really brilliant. So what is Mesos itself? The master, I said this is a two-level scheduler. I also said that Mesos itself is one exe that runs in two different modes, a master mode and a slave mode. All right, so Mesos, when we say Mesos, it's the master and slave. The second level scheduler is this thing called a framework. And it might be easier to look at this picture. So here's a common topology. I'm usually going to have a quorum of zookeepers. Zookeepers today within the Mesos world are used for two things. One is leadership election of the master. So you would typically have more than one master. The default, you have to have at least one, right? In a dev environment, you would have one. In production, you would have three, and we educate many to go with 5. So it just depends on how much availability you want and what your tolerance for risk is. The reason for 5, one, it's a quorum, so you need an odd number. 2, if you only had 3, if you took one down for maintenance, quorum rights are 2. If you had one fail while you had one in maintenance, you wouldn't have quorum rights and you'd have a failure. So 5 gives you the ability to provide maintenance with fault tolerance all at the same time. That's the reason for 5. It's a pretty simple reason. A quorum of zookeepers, we got the masters, we have slaves. Now here's the beauty. If I create an image for a slave or an agent, I just spin up another one, and I've added more resources. So adding capacity is nothing more than spinning up another instance of a slave. That's it. You don't have to have anything installed on it. It needs an operating system, and it needs the slave agent. It's about it. That's like the bare minimum requirements. You might need more depending on what you're doing, but that's the core of it. The other thing that Zookeeper is used for, when I said leadership election, the other is for master discovery. So the slave will contact the Zookeeper, which is in a well-known location, to find out where to talk to the master, and then magic happens. Right? That's it. As soon as the slave spins up, it will discover the quorum, it will discover the master, now you have more resources. If I want to take down resources, I just kill it. It's just like node goes away, right? There's some more elegant solutions than that, but that's an option. So a typical topology might look like this. I have just a cluster of things. I have every box on here could be a node. A very common solution would be to have zookeepers and masters on the same node, though. So, but you could do it this way. Thing to note about Mesos, which if you're just getting started is useful to know, everything is distributed and everything is asynchronous. And I mean everything, and it can confuse people. Like the thought process doesn't think that way, and I'll explain what I mean in a second. Here we could say this row of slaves is one fault domain. That's a second fault domain. That's a third fault domain. When I have something that fails on the first fault domain, I could reschedule it in that same fault domain. It magically will happen for me if you set it up correctly. There's some work to do to make that happen. When I said everything happens asynchronously, here's what I mean. Here's an example of a scheduler providing the intelligence of what to do, right? Again, Mesos itself, it just knows that I need this task to run, and so it sends it to a slave and it runs it. That's what it does. When that task fails, it will report back that this task failed. It has no idea what to do about that. Depends on your scheduler. Marathon is about long-running processes. So what it will do is like, oh, crap, I want that running, so start that again. Right? That's what it does. That's pretty much all it does. Now, there's a couple of communication points with Mesos. Anything internal to Mesos is protocol buffers. Everything internal is protocol buffers. So any communication of the scheduler to the master, master to slave, slave to executor, all of those are protocol buffer. There are usually, and for Mesos and with Marathon, there are RESTful endpoints. Those are RESTful JSON endpoints, no longer protocol buffer at that point. So things that I connect to externally usually are RESTful endpoints. Everything internal is protocol buffer. All right? Now, as I mentioned, everything's asynchronous. So when the scheduler comes online, what will happen is it will discover where the master is and it will register. Guess what? It doesn't know anything at that point. That was an asynchronous call. It has no idea whether that call was successful or not. It doesn't know anything. It knows that it made a request to register. There is a callback from the master that calls back to the scheduler and says, you're registered. That's how you know that you're registered. Everything is asynchronous, which gives us a number of benefits when it comes to fault tolerance, by the way. There's reasons for it. So that's the core of it. That's kind of the communication chain. Some components on here that might not be familiar to those who are new to this. We've talked a lot about what's sandwiched in here. The master and the slave is essentially Mesos itself. It's the first level of scheduling. The intelligence is whatever scheduler you created. There's several that are out there. I am an Apache committer, and I work on HDFS, on Cassandra, on Spark, on Myriad. You have a gentleman here that's actually created another scheduler for you guys, which is cool, using Solar. So that's pretty cool. That takes a certain amount of effort to do so. So that's what the scheduler does. When would you create your own? Anytime you have a need to orchestrate services in the data center in a unique way. If you just need something that stands up, you've got Marathon. It does it for you. But in the case of like HDFS, what you need to do with HDFS is I need to create a journal node. And once I have journal nodes in place, I can create name nodes. And once I have name nodes in place, I need to create data nodes. I need a way that understands how to orchestrate that, and if I have a failure in between there, what to do with that failure. So it's a little bit special. I could just start everything up by Marathon, but then I lose the ability to solve high availability issues in a way that's unique to HDFS. Right? So that's when. So another example, I think I might hold on to that. The other component here is the executor. It's the thing that knows how to launch things off. We launch off tasks. Now, that seems like an abstract concept, but there's a reason for it. The task that a job might run, it may be a thread or it may be a process. And so it just depends on the executor and the service that's being run as to what's actually the implementation detail of that concept. But a task is a job, right? It's the thing that you're running. So that's the core of it. And a couple more things, and then I'll finish off and take some questions. Essentially, it's like an OS kernel. I have a couple build-up slides, but it looks like this. If we looked at a Linux or a Unix-based platform, you would have Linux, and then you would have an init system, and then you have applications. Now, here's the cool part. If I created an app like MySQL or a Memcache or something like that, it doesn't have to know about the kernel. It's an application. Like, as a developer of that application, I don't have to know kernel stuff. If I'm writing up against the kernel, I'm probably creating a driver. Does that make sense? Like, I'm building an application, I don't have to worry about the kernel, generally speaking. Now, if we switch this to a Mesos operating system, or a DCOS operating system, we have Mesos at the kernel level, and we have Marathons, our init system. And we can start applications on that. And the apps that we're talking about here is Rails and Redis. They don't have to know Mesos. They know nothing about Mesos. If you were going to write an application that talks to Mesos, you'd probably be writing a driver. And the driver in that world is called a framework. It's a scheduler. It's the thing that has intelligence to tell Mesos what to do when bad stuff happens or how to orchestrate something. And the core of this looks like this. This is, the kernel is Mesos. We have a bunch of aggregated services, and I have either native running apps, I have long running apps, I have essentially cron type apps, or maybe some analytics type stuff. So, where are we? Okay, I am pretty much out of time. I have a few minutes. So I'm going to go ahead and answer questions. I want to stop and look at this, and we still have an unhealthy Cassandra. So, I'm an idiot. So I only had an hour on that cluster, and I lost that cluster. Dang it. All right, well, I just created another one, but it'll take too long. It'll take more than 3 minutes to get it started. So any questions on what we talked about? The future of the data center and the future of where we're going with application development in the data center is definitely going to be about containers, and it's definitely going to be about dynamic and elastic services, the ability to react within seconds. I'll also add that at Twitter, among other places, they will do non-production-like things in a production cluster, knowing that if something happens and they need the resources, they will just deprioritize the non-production stuff and be able to consume those resources for production reasons. So that would be like taboo in most organizations, but they're doing it. Some pretty cool stuff. So, questions? Scratching your head. Oh, one. All right. There is a mic.
All right. So you mentioned some gotchas when it comes to Java-based technologies over this. So I'm going to put you on the spot because we use a lot of Java here. So can you elaborate on that a bit?
Yeah, I've been meaning to blog about this for 9 months now, and I just never get time to do it. There's a bunch of build-up to get there, but I'm going to try to do it really shortly. You have to understand C groups, and what C groups do is provide isolation. For memory, it's pretty clear and cut. They have a soft kill and a hard kill, but I've only ever seen in the real world hard kill. So it's basically a kill-9 if you bump up against memory. So that's one thing, and it's not a big deal. Where we run into issues is for CPU management. CPU management C groups has 2 specs. One is CPU sets and CPU shares. CPU shares are the general way that people typically use, and in fact is encouraged by the latest research that Google put out on their research site, so you can get more information there. But the way it works is this. CPU sets is like I land on a 24-node box, core box, and I say this thing gets 3 cores. It gets cores 0, 1, and 2. So it has 3. If you were in the JVM to say, runtime, give me the number of processors, it would say 3, because that's what the core set is. I'm defined to 3, and I have affinity to them. If you're doing NUMA-like stuff, and if you have a heavy hit against the L1 cache, that would be a good thing to know about, because you would get some value out of it. Generally speaking, when people stay away from it, they go to CPU shares. Now, here's how shares work, though. Shares mean I give a weighted priority to my container. This is container issues, not Java at this point, right? So I say I have, essentially this thing gets 2 cores, but I land on a 24-node core box, right? If you went into the JVM and said, tell me the number of cores, it would say 24. Now, the problem with that is you start to need to put a bigger picture together. I used to teach a lot of memory management and pretty low-level Java stuff. The things to know to really keep it short is that the number of cores dictates a couple of things. One is it's a heavy influence on the number of threads for GC. It is also a heavy influence on the number of threads in the fork join pool. And for my Lambda friends out there, who are all the cool kids doing parallel streams with Java 8, right? The parallel streams uses the fork join pool. So the problem that you run into is the realization, the real number of cycles that you get as a Java process is roughly 2, but I'm actually seeing 24, which means I have more threads than I have cores, which has a negative influence on a number of things. One is they call it the save point, the time to save point, as well as the other thing you have is you have different runtime characteristics, especially at heavy load, between landing on a 8-core box and a 32-core box. And that's like not acceptable, right? That's just crazy not acceptable. If you're in a production environment, the one thing you're after is always having the same characteristics always. So there's a number of issues there. I could go into more detail, but the core of it is that. The core of it is the number of threads you get is equal to the number of cores, and the cores that you see versus realize is different in the JVM. So, and there's no solution. It sucks. I'm good friends with Brian Getz, who's chief architect of Java language, but he's the language guy. He's not Mark Reinhold, who I have no influence on it whatsoever. I can't say that I have influence on Brian, really. He's just a friend. But. Any other questions? This is like being in Norway. It's like a bunch of Scandinavians.
Hi, I had a question about, you talked about when you're firing up that Rails app and all those various resources that got spread around the 20, they're self-registering with HAProxy. So is there a single HAProxy instance that's just deployed with a Mesos
So that's
cluster?
up to you as to how you manage that. In that particular scenario, what we had in place is something that's registered with Mesos that would see that there was something added, and then it would add it into Mesos. Oh, well. One option is to add it into Mesos DNS. In this case, it actually added it to the HAProxy config, and then did a bounce on it. So it is real, it does work, but it's not. This demo is primitive, and I would probably do some different things. But.
Okay, so if you were to install 2 versions of the same application, maybe latest versus what's been out there, you'd have to do some other something outside of Mesos to kind of manage.
Well, the script is pretty much in your control for how registration at HAProxy happens. So you would have to come up with a scheme to manage that. We do for that particular scenario. We are coming out with a product shortly, which is called Minuteman, and I believe that's one of the scenarios that they're trying to solve as well, is kind of an upgrade strategy on versions of apps. Don't hold me to that, but I think that is one of the things on the, if it's not part of it, it's part of the roadmap. So, yeah, it's a good question. The other thing that's really cool about that, I think, is that the script that we have doing that uses the RESTful endpoint. So at that point, you have an example of what you can do, and you can take full control over whatever you want to do, right? So now what we're trying to do is build a whole operating system that has kind of best practices already baked in, where you don't have to worry about those kind of details. And so we're still on that roadmap, right? Questions? In the back.
So some of the stuff you showed processing, Hadoop, Spark, gets value added out of data locality.
Yep.
But if you have a data store and say you're processing both running on something like Mesos, how much of a struggle is it to keep the two together to get that performance benefit? Or how much, I guess, in production systems have you had, like, seen the performance hit of those two not being located together?
Yeah, that's a great question. We're still working towards some better solutions for that. I can think of ways where you could manage the locality of things based on constraints, which means using attributes. It begins to feel like a statically partitioned world and a dynamic world, if that makes sense, or I've allocated certain nodes to be special in some way. But it is a way that works. Aside from that, it's a known thing that we're interested in doing. We're trying to build out the infrastructure to enable that type of behavior, but we're not there yet. Does that make sense?
So the running of things like HDFS and those systems on Mesos, have you had experience with consumers actually doing that in production, or is it kind of a proof of concept pet project?
Well, that's a tough question. I don't know if people are using it in production. I believe we have some, but I would say this. I'm actually one of the developers now on HDFS, and I would say that the code that has been there in the open source space is best looked at as a proof of concept. I am working to fix that today. There's also, there's a bunch of things I'm working on now in that space. One is decoupling the framework itself from HDFS, which currently it's tied to it, which is ridiculous. It doesn't need to be, which I've already done. That's fixed. The next level is making things dynamically updatable, where you can actually change configs on the fly. That should be done this week or next. And then the next step would be doing on-the-fly upgrades of services. So currently, the underlying HDFS is 2.5. When you install an upgrade, you should be able to have the framework make the underlying service changes of 2.5 to 2.6 or 2.7. So that's all going to happen within the next quarter, if that makes sense. So that we feel like with that and a couple of other things makes it a real enterprise solution. Without being able to update or upgrade, it's ridiculous. You're not really, like as an enterprise, it doesn't feel good. So we want people to feel good, right? It would be wrong not to. Any other questions? Oh, yeah, in the back. Dead center in the back. It's perfect. Throw it. Oh, you guys are safe around here. It's conservative. Midwest, sorry.
So it really looks like it's geared towards developer happiness, right?
Yeah, I'm happy. You?
So, yeah, I was wondering, how do you guys handle things like log aggregation across my apps? And also, like for deployments, right? Like how do I, like at a Heroku style, do like a git push, right? Is there anything built in today or in the future that will allow me to like do my own code rules and also like check all my logs across all these disparate systems?
Yeah, that's cool. Yeah, good question. So today people are kind of, we've been helping people either roll their own or use like Logstash or something. It seems to be like a common thing people are using with Docker and Docker with Mesos. Our infrastructure team internal to Mesosphere is working on a solution for exactly that. So it's not out yet, but it's definitely on our roadmap and probably short term. But do you know that or not? Yeah, he's checked out. It's definitely on our roadmap. And I mean short order, like within the next quarter, I think. What was the other question? Oh, the Heroku style. I'd say no on that. I don't know of any solution in that space right now. I think the closest thing that I've seen, it's not a Mesos solution, but it is a PaaS type solution, is Deis. Deis's focus is Docker with a workflow that is extremely Heroku-like, and then into CoreOS, essentially, which you could consider to be somewhat competitive, but it's kind of frenemy world, right? Like I don't know, we're friends and we're competing friends, right? So, but I don't know of anybody working on something like that in the Mesos world. It's a good question. Doesn't seem very hard though. Like, I don't know. I could be wrong. If it were easy, it'd probably be done, right? I will say, though, that one of our initiatives internal to our company is developer agility. So I mainly work on the data agility team. What I'll be working on over the next year is taking the Lambda architecture, essentially actor pattern like Akka inbound. It's an Internet of Things infrastructure, essentially. So Akka inbound into Kafka, into Spark Streaming, into Cassandra. And I believe the specs they give me is 1K writes per second. So I don't know how I'm going to do that yet, but that's my job. And then, but we do have a dev agility team, which maybe what you're asking plenty of questions about. And if you have more, send them my way, and I'll make sure they get to the right person. But we have now established Jenkins on top of Mesos in a really healthy way, and that might get you closer to what you're looking for, where I do a build, Jenkins takes it over and Dockerizes that, and then from there, you'd have to go a step further, though, right? Something gets done, you want to push it into service. That piece is not there as far as I know. It's a good question. Anything else? You guys just want to go home? Me too. So, all right, well, thanks. Appreciate it.